Let's continue our introduction to pop nets by furthering our look at forces while also looking at some other nodes like pop drag, as well as gravity and spin. So as always, this project file, along with all the previous episodes, are available on Patreon. So if you want to grab them, you can do so on there. Let's drop down a SOP create. Let's dive inside here and let's drop down a grid again. And again, we can just make this a 2x2 grid. Let's move it over. So we have one grid over here, and then we're also going to make another grid that is 2 units over in the X direction. So we're going to take a look at some speed limits here. So we'll take a look at the pop speed limit node. So let's add a attribute wrangle. And actually, let's add a group before this. And we're just going to wire this in. I'll make a group for both streams here. We'll call one velocity and we'll call one force. And with this, let's just go ahead and add a velocity vector. So v at v is equal to set. And then again, we're just going to set this to be up in the y direction. And we'll just make a copy of that and do the same thing for our attribute wrangle for our forces. And let's drop down and merge here. We can wire these in and we'll drop down a pop net for here as well. So now if I press play, we're going to have just our particles moving up here. Let's go ahead and apply a force here. So we'll do pop force. And I'm going to enable our group and let's just set that to the force here. And let's set the force to be a value of 1. And if I press play, as we expect and we've talked about in the past, our force is going to accelerate our particles past that velocity on the left here. So if we wanted to slow these down, because as we've talked about, velocity is going to be limited to a value of 1. So if we look at our geometry spreadsheet here and we look over at our velocity, you can see we have this value of 1. So that's all these particles on the left here. And then on the right, they're moving faster than that because they're being applied a force. So the force will move past a velocity vector. If we wanted to limit that, we can use a node called the pop speed limit. We wire this in and then we can set the maximum speed here. We also have controls for the maximum spin as well, which we aren't going to look at right now, but later on, after we look at the pop spin node, you can apply that to the same thing as well. So if I set this to a maximum speed of like 2 and I reset and play, you can see that we're now getting the particles stopping at a maximum speed of 2 in the y. So if I set this to 1 and I restart here, you can see that we get the exact same thing. So we can use this pop speed limit to limit the effects the force has on our particles, and that's going to be useful for just maintaining control over them. So let's drop back out and let's do the same thing here. Let's copy these over. And instead of a velocity group, we'll call this one drag and no drag. And we'll take a look at the pop drag. So let's drop down that merge again. We can wire both of these in here, and then we can wire in a pop net for this as well. So let's jump back to the start here. And again, we're just going to drop down a pop drag. And without this, if I go ahead and press play, you can see we have just our particles moving up like we expect with our upward velocity. But if we enable our group here and we set this drag group in here, we can press play. You can see that our particles start to slow down. Now, a little bit interesting note for how this actually works. If we hover over our wind velocity here, it says this is the speed at which the particles will be dragged to. So if we set this to a value of 0, it's going to slow them down to a point where they're hit 0. And the more that we increase this air resistance, the quicker that's going to happen. So if I increase that, you can see that they approach that non-moving speed a lot quicker with the air resistance set up higher. So let's reset that. And let's talk about this wind velocity and what this means. So the speed at which the particles will be dragged to. If we look at our geometry here and come over, any node that has a wind attribute applied, or a wind, it's not even a wind attribute. It's just anywhere you see wind being applied in a node, if we come over in our geometry spreadsheet, it's going to create this target V. So this is the target velocity. If I change this, you can see that it's going to change the velocity at which the target V is set to. So this is the target velocity that it is trying to get to. So anytime you have a wind in wind setting in any of your pop nodes, it's going to apply this target V, and it's going to try to push the particles, or pull the particles, I should say, to that target velocity. So if I set this to like 1 in the X direction there, I press play, you can see it's going to pull our particles over now. And you can see that they're slowly approaching this value of 1 in the X direction here. You can see that they're slowly getting closer and closer to this target velocity that we have set. Even though that we have this air resistance set, it's going to drag them to whatever target velocity that we have set, or whatever wind velocity that we have set. So just keep that in mind. That's kind of how that works. We can just reset that. And again, we're just going to have our particles slow down to a stop. But if you want them to continue to move, just get dragged to a different position. This is one way that you can do that. So let's take a look now at different ways of applying forces. So I'm going to just copy over these nodes once more. And with this one, I'm going to call this one pop force. And I'm going to call this one wrangle force, because we can actually create forces using the wrangles. So if I drop down a pop net, let's dive inside here. Let's start at the beginning here. And if I just take our pop force, drop that down, and I set the velocity to 1 in the Y, you can see this is what we're going to get. But let's apply it to just one of those groups, so the pop force group. So if I press play, you can see we have one of our particles moving. So if I come to our geometry spreadsheet here, you can see we have this force that's being applied. So again, this is just an attribute that we're having created with this pop force node. So if we do a pop wrangle, we can drop this down. And again, we want to make this a vector. So we'll do V at, and then we'll just call this, V at, and we'll call this force is equal to. And then with this force, we can set to whatever we want. So we'll do, again, set, and we'll set this to 1 in the Y. And once I press play, restart it here, we should see the particles moving the exact same here, which we have. So I just wanted to point out that you can actually create some of these yourself, and create forces with wrangles, and do all sorts of interesting things inside of wrangles in order to get these pop force type of effects, but with a little bit more control in the wrangle if you really like to work with code. So the last thing I want to take a look at is going to be gravity and spin. So let's take our grid here, and let's actually, we only need the grid. Let's add an attribute wrangle. And we're going to create a velocity attribute. So we'll do V at V, and I'm going to make this kind of extreme. So equals to set, and I'm going to move these up quite a bit. So 10, and then I'm also going to move them over, I'm going to move them over, and then I'm also going to move them up. So we'll start off with a value of 10 for the X and Y, and then we'll drop down a pop net. So now if I press play, you see we have the particles just kind of shooting off in this direction. So if I wanted to add a gravity force to that, we can drop down a gravity force. And we're going to wire this gravity force not up here where we've been wiring everything else. We're going to do it between our pop solver and our output. So I can wire that in. And if I press play now, we get this type of fountain-like effect going on here. So the particles are being shot up and over because they've got quite a bit of velocity being applied to them off the start. And then they have this force that's being applied to them. And this is negative 9.8 meters per second. So this is actually in real world scale. So this is the actual value that's being applied in real life. So keep that in mind. Now, also, I just want to point out, if we look at our geometry spreadsheet here, we have this force that's being applied. So if I look through our attributes, you wouldn't find anything that is gravity like we see for the data name here. So the way that this works is it's like a sub attribute. So if I hover over this, you can see it says indicates the name that should be used to attach the data to an object or other piece of data. If the data name contains a backslash or several, that indicates traversing inside subdata. So basically it's being applied inside of this force attribute, but it's like a subdata attribute of it. So you're not going to find it in your geometry spreadsheet. Just keep that in mind, but that is how that works. Let's drop down a pop spin though, and we can take a look at that as well while we are here. So if I look at the spin node, we have some attributes that we can, or some parameters that we can affect here. We have axis relative to particles orientation. We also have an axis that we can specify for our spin. And then we have this spin speed. So the spin speed is going to be the most important thing. And you need to remember that this is in degrees. So if we crank this up to something pretty large, like 180, it's going to apply this spin to our particles, but we're not going to be able to really tell inside of our pop net. So let's jump out here. Let's drop a cube down. Let's give it a size of like 3. And then I'm going to drop down a transform node. Let's take a look at that. And I'm going to select these top points here. And I'm just going to scale them down so we get some sort of cone-like shape. And then I can do a copy to points. Wire these in. And I'm going to jump inside our pop net and really drop that birth rate down quite a bit. And now if I press play, you can see we have our cones that are being applied to our particles, and you can see that the spin is being applied to them as well. They're spinning throughout space, and you can get some nice effects with this as well, depending on what you're trying to do. You can play around with the axes if you would like, but that is how it's going to work. Let's go ahead and just add some into the X there. And if I press play now, you can see how that affects our particles. So hopefully this has helped you out. I have a bunch of other videos on pop nets. If you haven't checked those out, if you want to learn more about pop nets and you're just getting started, then I definitely recommend taking a look at those, but we're going to continue to dive deeper into them as well. I also have a bunch of other videos on my channel that show how to do a bunch of different things. So if you're interested in learning more about Houdini in general, then make sure to check those out. And like I said, this project file, along with every other project file for the series and a bunch of other project files, are available on my Patreon if you'd like to grab them on there. But anyways, hopefully this has helped you out. Thank you guys for watching and have a good day.